Hello all. Welcome to this video. In this video I am going to explain the adaptive frequency sweep application that we have developed for Matlab RF PCB Toolbox. The adaptive frequency sweep technique is based on approximation of mathematical function, which adaptively chooses the simulation points depending upon the specified error criteria. This method can be used to reduce the computational time without any compromise in accuracy. In this work we have incorporated Davide Predovera's minimal sampling algorithm for adaptive frequency sweeping in electromagnetic simulation. The input file button in this application allows the user to enter the structure to be simulated as .mat file format. The user can then set the minimum and maximum frequency of simulation in gigahertz. The sampling frequency, which is the frequency interval set to generate output S-parameter data, is initially set at 10 MHz, but the user has the option to modify it. When you enter the file, the port number is updated automatically. By selecting the frequency points adaptively, the application will generate the S-parameter data over the given bandwidth when the Simulate button is clicked. The application will automatically plot the S-parameter data in the graph following the simulation. In addition to choosing the magnitude or phase plot from the drop-down menu, the user can change the input and output port numbers. The plot button allows the user to plot every S-parameter. At last, the user can save the touchstone file of the S-parameter data. Okay, that was the introduction. Now let me show you an example. We are going to simulate a step impedance low-pass filter through our application. For that we have to save the structure as .mat file. Here we are saving the structure as PCB_port.mat. This is the first step before entering the app. After saving the structure as .mat file format, we can go to app. By clicking the input file button, we will input the saved mat file of the filter. The sampling frequency is initially set as 10 MHz and the port number is updated automatically. Here we are simulating the structure for 1 to 10 GHz bandwidth. After that, clicking the Simulate button, the app will simulate the structure. It will take almost 6 seconds to generate the result. Here the input port and output port is set as 1, so it will directly plot the magnitude of S11. In the graph, the black dot indicates the frequency points the algorithm has chosen automatically for simulation to generate the results. In this 2-port example, 21 frequency points are chosen within the given bandwidth to generate the S-parameter data. Now the user can change the input and output port number and can plot corresponding magnitude or phase plot by clicking the plot button. Finally, we can save the S-parameter data over the bandwidth with an interval of 10 MHz. Here I am saving the S2P file. Now we have to test whether the generated data is accurate or not. For that we have to do manual simulation in Matlab from 1 to 10 GHz with an interval of 10 MHz. For that, first we will load the mat file of the same PCB structure. This simulation will require 901 frequency point to be simulated within the bandwidth, and it will take time. Okay, the simulation is completed. We have saved the S2P file. The time taken to complete the manual simulation is 180 seconds. With our app, the simulation is completed within 6 seconds. Next, we will check whether the data generated from the app is accurate or not. For that, we will load the S-parameter file generated from the app and the manually simulated data file. Here the first S2P file is the 10 MHz interval data generated by manual simulation, and the second one is the data generated by adaptive frequency sweep. We will plot the magnitude and phase of S12 and S22. In the graph, the solid line indicates the manual simulation data, and the dotted line indicates the app-generated data. From the graph we can see that both data is perfectly matching. We can check the other parameter also. So, we can see that our app will significantly improve the speed of electromagnetic simulation without any compromise in accuracy. I will show another example. In this example, I have already created the mat file of a 10-port PCB structure. In this example, we will simulate the structure for 1 to 5 GHz frequency band. As the structure is complicated, adaptive frequency sweep will take some time. For this structure, the adaptive simulation took 5 minutes to generate the data. The manual simulation of this structure in Matlab with 10 MHz interval will take almost 1 hour. We have tested this app with many examples including 10-port and 44-port structures, and it is generating accurate result by significantly improving the simulation time. Hope this app will help the Matlab RF PCB Toolbox and Antenna Toolbox users to save their time for the electromagnetic simulation. This app is developed using Matlab R2024B. Thank you for watching.